The use of subassemblies has many advantages in SolidWorks. Subassemblies make larger assemblies easier to manage. They make it easier for multiple users to collaborate on a single large assembly design. They can also affect the way you document your large assembly design at the 2D drawing level. For these and many other reasons, it's important for you to be comfortable creating subassemblies in a variety of ways. This is the focus of the next few lessons. The easiest method of creating a subassembly is to simply introduce an existing assembly into another assembly. This process causes the inserted assembly to behave as a subassembly. In this case, I'll insert a new component. Instead of selecting a part file, I'll browse for an assembly file and select the crank assembly. You can see in the Feature Manager tree, the crank assembly is listed using the assembly icon. If I expand it, the components that make up the assembly are shown. Even in a simple case like this one, there are advantages to using subassemblies. For instance, the process of mating these components is simplified. Since subassemblies behave just like single components, all I have to do is create mates for the crankshaft component. Once it's positioned, the entire subassembly is positioned correctly. Also, by having this crank assembly created ahead of time, it can be used in any number of other assemblies. Without the use of subassemblies, I would have to add each of these parts individually and create the mates necessary to position them in each and every assembly. Another practical use for assemblies is to group components together that can be easily hidden or suppressed. If I want to hide all components in the crank assembly, I simply right-click the subassembly and select Hide. To bring them back, all I have to do is select Show. In addition to creating assemblies ahead of time, you can also take individual components that already exist in the assembly and make them into a subassembly. For instance, at the center of this assembly are 3 pins and a spider. I'll select these components from the Feature Manager tree, holding down the Control key on the keyboard. This allows me to select all 4 components at the same time. Next, I'll right-click one of the highlighted components and select Form New Subassembly here. Since a new assembly file is created, right-click the assembly in the Feature Manager and select Rename Assembly. I'll call it Moving Parts. The Moving Parts assembly is now listed in the Feature Manager tree. You can see the spider and pin components are listed within the Moving Parts subassembly. Notice all components have a minus sign next to them. Typically, in a newly created assembly, the first component is fixed. When assemblies are formed in the context of other assemblies, like we did here, there are no fixed components by default. To make one of the components fixed, you must first open the subassembly in its own window, then right-click one of the components and select Fix. Now, this is not required, of course, but it's a good idea to have at least one component in your assembly fixed so the entire assembly isn't free to move arbitrarily in space. I'll save and close the assembly to return to the top-level assembly. Since the male and female yokes are also moving parts, we should probably add them to the Moving Parts subassembly. Now, this is very easy to do. I'll simply click and drag the yoke male component and drop it onto the Moving Parts subassembly. You'll notice an icon appear with 2 arrows pointing in opposite directions. This is the Promote/Demote indicator. It tells me that the component I'm dragging will be demoted to a subassembly. I can also drag a subassembly component out of the subassembly and promote it to the top-level assembly. Next, I'll repeat the process with the yoke female. This time, when I demote the part into the Moving Parts subassembly, a warning message appears. And this message warns that an exploded step defined for the yoke female will be deleted as a result of this move. Promoting and demoting components affects the structure of the assembly. The structure can affect things like mates, assembly features, patterns, and as you see here, explode steps. Be aware that by accepting moves like this one, you're agreeing to move or possibly delete the affected features. For details on this behavior, see the SolidWorks online help and search for Effects of Assembly Structure Editing. In this case, I'll click the Move button to accept the move, and the yoke female is now part of the moving parts subassembly. Unfortunately, by doing this, the entire assembly no longer moves. Remember that a subassembly behaves like an individual part. It's rigid. To change this, all you have to do is make the subassembly flexible. In the next lesson, we'll take a look at how to allow motion within a rigid subassembly like this one.